Hello friends, welcome to Biosumit. Today we will learn about the fundamentals of mass spectrometry. So here you can see that a mass spectrometer can only analyze ions in gaseous stage, and that is also positive ions. So let's say the first thing, why we will use the mass spectrometry. It is nothing, actually it can measure the mass of a molecule, like for analyzing some peptides or amino acids or proteins. You can use a mass spectrometry to know the mass of that unknown thing. Now it measures only the mass to charge ratio. So I have told that it will measure mass, but it's not. It actually measures the mass to charge. That means mass means m and charge we denote as z. So it will measure m by z. And what is mass spectrum? What we will get at the last, like you can see here, the 2D representation or graphical or tabular of the distribution of intensity of the ions introduced in the mass analyzer and then separated and recorded as m by z. So in this method we will measure the mass is to charge, that means m is to z or m by z. So what is m in m by z? Like what is m? It is the unified atomic mass unit, or in short AMU. You can say that a dimensionless number that will be defined so that a single C12 isotope that will contain 6 proton and 6 neutron has a mass of exactly 12 U. 1 U means 1.66 into 10 to the power minus 27 kg. Dimensionless number that is defined so that a single C12 isotope that contains 6 protons and 6 neutrons has a mass of exactly 12 U. So for example, let's say 2 protons are added. 2 protons means m equal to 2 and z equal to 2. Now suppose the mass of the molecule was 399. So now the m by z will be 399 by 2 plus 2 by 2. So what will be 401 by 2. So we can get this type of values, and from that we can assume or we can get the mass of that unknown compound. Now we'll learn about the basic principle. Now as I said that atoms here or the molecules will be measured through their m by z ratio, right? So here are 4 stages of this mass spectrometry. So the first stage is stage 1 is ionization. As I said before, the atom is ionized by knocking one or more electrons off to give a positive ion. So it has to be a positive ions. Mass spectrometers always work with positive ions. Remember that. The second stage is stage 2 is acceleration. What is that? Here the ions are accelerated as its name suggests. Why? So that they will have kinetic energy. We'll discuss later about all the things. Now the third stage, that is deflection. So in mass spectrometer there will be one magnetic field. Okay, so atoms can be deflected by magnetic fields if the atom is first turned into an ion. Okay, so atoms get deflected due to magnetic field. Now this deflection differs, like if the mass is lighter, then deflection will be more. Also it depends, it means that deflection depends on the charge of the ion 2. Charge more means deflection more. Now the final stage, stage 4, is detection. As it suggests, that the beam of ions passing through the machine is detected here. How? Electrically. Now if we draw an overview of the mass spectrometer, so first there will be one inlet, that means here will be the sample introduction thing. Here you will keep the sample in sample, and then there will be a big vacuum chamber. Here we will have the ion source. Here will be the ionization will happen. Now there will be one mass analyzer, one or more than one mass analyzer. It will separate the ions by m by z separation, and then there will be detector, and at the end there will be one computer. So this is the overview of a generalized structure of a mass spectrometry. We will discuss in details about what are the inlet ion source, mass analyzer or detector, and it can be varied the ionization method with the variation of ionization method. Like the ionization method also vary if the phases of that sample will be different, like so for solid, for liquid, for gaseous samples, the ionization methods will be different and the mass spectrometry will be also different. Now here I have said that there will be one vacuum chamber. Why vacuum chamber? Because the ions produced in the chamber can have a free run through the machine without hitting air molecules. Remember in the acceleration, I have said that here the ions are accelerated so that they will have the kinetic energy. So to have the maximum kinetic energy, it needs the less amount of resistance or no resistance. So that's why the chamber is vacuum or void. So this is just the basic of the mass spectrometry, how it is happen or what is. So first stage is ionization. So here the vaporized sample passes into the ionization chamber and it will create positive ions, right? Then it's acceleration. So what happens here, the positive ions are repelled away from the very positive ionization chamber. The ionization chamber is positive, so positive ions will be repelled away, and there will be so many slits here. You will see later so many slits, like 3 slits, and there will be some different voltages. There are the slits. Okay, this is the intermediate plate, and how and the ion beam will pass like this through the slits. Then comes the deflection. So it will be deflected by the magnetic field by different amounts. It will depend on the mass of the ion. Mass is lighter, that means deflection is more, and also charge of the ion. Charge is more, that means deflection is more, correct? And finally there will be detection. The beam of ions will be passing through the machine, will be detected here. So this is the overview of a mass spectrometry. Now there are so many variations of mass spectrometer. As I said, the ion sources, the on the basis of ion sources there can be so many mass spectrometers like ESI, APCI, MALDI, DART, DESI, etc. On the basis of analyzer, here you can see the mass analyzer. It can be FTIzer, quadruple ion trap, time of flight. So many type of variations there. In terms of detector, there can be electron multiplier. So we will learn those things in next video. Thank you.